Customers using a self-service soda dispenser take an average of 12 ounces of soda with an standard deviation of 4 ounces. Assume that the amount would be normally distributed. Let me take X for the amount of soda. Then X has normal distribution, mean equal 12 and standard deviation equal 4. So standard deviation is a sigma. The part A, what is the chance that a randomly selected customer takes over 10 ounces of soda? Let me draw the density function. So this is normal, therefore it should be bell shape, and in the middle mean should be 12, therefore middle number should be the 12. Now asking customer takes over 10 ounces of soda. So 10 should be less than 12 and maybe over here. So chance, what is the chance? Chance means the probability or area under the curve and right to 10. So this is the area. Now we need to find, it means probability. How do we write this in notation? Probability, we use X for the amount of soda. Therefore X, here asking takes over 10 ounces. Therefore greater than 10. So this is the probability X greater than 10. Then according to our table, we should write down this 1 minus X less than. Why? Because X greater than. Therefore, I will write down 1 minus probability X less than 10. Now, what is the next step? Yes, here 1 minus. We need to convert this X to Z. How do we convert X to Z? Z equal X minus mu over sigma. So what is the X value for this? X equal 10 here. So 10 minus mu equal 12 and sigma equal 4. Therefore this should be negative 0.5. Now we can write this probability Z less than negative 0.5. Now what is the next? Next, 1 minus, we need to use the table to check this. How do we check? Okay, Z less than negative 0.5. Therefore, go to the Z table. Then you see here negative 0.5 and go to the top and 0, 0. So then find the number here. Let me explain this. So this is the Z table. You see we need negative 0.5. So go to the negative 0.5. Yes, you see this one is the negative 0.5. So this is the 0, 0. Therefore, this is 0.3085. So probability Z less than negative 0.5, this equal 0.3085 and answer is 0.6915. So we can say we have 69%, approximately 69% chance to take over 10 ounces of soda. Part B, what is the chance that a randomly selected customer takes between 13 and 14 ounces of soda? Alright, now they are asking between 13 and 14 ounces. So let me draw again density curve. This is the 12 because it is the mean average. 13 should be over here because greater than 12 and 14 here. So asking the area under the curve and in between this. So let me write this in notation. Probability X is the amount of soda and this less than 14, or you can use less than or equal, here 13. Okay, then what is the next step? Whenever we have in this form, in the like a range, upper bound and lower bound, then you should write down this x less than or equal 14, first big number, here bigger one, then the smallest one. So minus probability x less than or equal 13. Always this is the case for this type of problem. Now we need to convert to the z value. Okay, so probability is z. So what is this number? Okay, let me show you over here. Now we know z equal x minus mu over sigma. So what is the x here? For this case, x equal 14. Therefore, 14 minus mu equal 12 divided by sigma equal 4. So this is 0.5. Therefore, this is 0.5 minus probability. Again, z less than or equal 13 now. Let me check. Z x equal 13 now. 13 minus 12 divided by 4. So this equal 0.25. Therefore, you can write down 0.25. Now we need to check the table. And now we have z less than or equal 0.5. Therefore, go to the z table. I am not going to show you now because you know the same way we use for this problem. But this case, go to the 0.5 here and 0.00 here and number over here. So this number should be 0.6915. Therefore, let me write down over here. This is 0.6915 minus this the same way. Go to the table here 0.2 and go to the top 0.05. Then find this number. That number should be 0.5987. So let me write here 0.5987. Therefore, subtract this 2, then 0.0928. So we can say approximately we have 93% chance to take between 13 and 14. Next one, what is the 80th percentile? Okay, now they are asking 80th percentile. This is the density curve. So again we know this is 12. So 80th percentile, what is that? So it is the probability or area under the curve and less than this point. This means 80th mean 80%. So you can write down 0.8. So I will write down with 4 digits 0.8000 because table gives the probability with 4 digits. So this is the number now we are looking for. I use that P80 or you can use X1 any. It doesn't matter. Again, here we have probability or area under the curve and we are looking for the number on this line in which is this. But before we did the opposite way. We knew this number and we were looking for the area. Okay, now let me write down this in notation form. Probability x, what is this? P80. P80, the area less than or equal P80 equal what? 0.8000. Now what is the next step? Next step, convert to z value. So z less than or equal P80 minus mu, which is 12 divided by 4. This equal 0.8000. Now we have to go to the table, Z table, because here again we know the probability and we don't know something in Z or something in this bracket. Therefore, we should use the table in opposite way. Let me explain. So this is the table. Now we are looking for 0.8000 in the middle of the table, but we cannot find that number. You see, we have this number 0.7995 and we are looking for 8000 and next number 0.8023. When we are in this situation, we go with the closest number. What is the closest number? 0.7995. Therefore, this is the number and then find the corresponding Z value for this number. It is Z equal 0.84. Now we know this is 0.84. So what is this? This is a Z value, right? Therefore, we can get rid of everything but this Z value. P80 minus 12 divided by 4. Then we can simplify P80 equal 0.84 times 4 plus 12. So this equal 15.36. Yes, this should be 15.36. But you know that here 12. So what is the area less than 12? It should be 0.5. Why? That is the middle point. Then 80th percentile should be greater than 12. Yes, it is 15.36.